In stats class, this is a problem from your final exam review, but it's coming from chapter 10 material. So we're doing a regression equation, linear regression, and we have the data set. So there's two ways you can do this. One, you can plug it into your calculator, or two, you can use StatCrunch. So let's start off the first example. We'll plug it into our calculator. So to do this, you hit Stat and go to your editor. Alright, I got stuff in there. If you got stuff in there, there's two things you can do. You can highlight the list, hit clear, and enter to clear a list. You can also hit second memory, and then right here, clear all lists. Alright, and if you have multiple lists and you want them cleared out, it'll clear out all of them at the same time. Okay, so I'm going to put all of that data in the calculator right now. Alright, now once I've got all the data in there, I'm going to press Stat again. This time I'm going to come over to Calculate. Calculate, and remember we're looking for y equals mx plus b, or sorry, b plus mx. And here is a linear regression equation, ax plus b. Just note it's backwards. If you want it to look like this with the x term second, you can just scroll down a little bit further. Before we'll do it, if I wanted to though, I could scroll down a little further and make the x term be second. That gives you both those options. I always just use for the, just remember to put a in front of the x term, and they switch it around like that. Alright, so linear regression. There's this. Now, if yours is only showing a and b, and it's not showing r squared and r, then that means you have something called your diagnostics off. So if you need r, which a lot of times you do, or r squared, you need to press second, catalog, and then you're in alpha mode when you see this A right here. And then diagnostic starts with D, so press the letter or the key that corresponds to D, and it skips you down to the D's, and then scroll down until you see diagnostics on. And when you turn that on, that will, once you run your linear regression, it will, not just linear regression, any of the regressions, it will display R and or R squared. Okay, so there's this. Now remember, A is what's with X. So A is actually the second block here. So that's one decimal place, so that would be 1.2. And B is the 29.2. Alright, now if you get this wrong, if it tells you that something's wrong, then more than likely you made an error putting your numbers in your list. Okay, because your calculator is going to compute that correctly as long as it's wanting a line and you select line. Okay, so if you get something wrong here, you won't know on a quiz or a test, but if you get it wrong on a homework, just check that you put all your points in right. If you're doing it for a quiz or a test, I would hope you would check 2 or 3 times before you actually ran it. Okay, because you could easily, with putting in that many points, you could easily make an error. Right, the best predicted gross for a movie with $125 million budget. Okay, the budget is the X values, and the gross is the Y values, the Y hat values. So what we need to do is multiply 125 as our X. So 125 times 1.2, which is what's multiplied by X, 1.22, and then plus 29.2. So 179.2. Alright, now we got a same problem, different data set, but let's say we want to do this with StatCrunch. When I see this little square out here at the end of the data set, I know that I can open it in StatCrunch. Alright, you can also open it in Excel or just copy it and throw it into Excel. But I'm going to open it with StatCrunch. Alright, and there's my data set. Again, you can move it over here and verify that that's the same data set. If I click on Stat, then I want to go to Regression, and then Simple Linear Regression. My X variable is budget, my Y variable is gross, and I want to do a hypothesis test for the slope to not be 0, okay, and then just come on down here to compute. Alright, so there is the same numbers for this one. Alright, there's the number in front of X, okay, the budget right here is our x. This is the number that's beside that, so 1 point to one place, 1.3. And then the number in front of the y-intercept is this, so 20.1. Alright, the best predicted gross for moving $150 million budget. So same thing, I would need to multiply this number times 115 and then add that. Okay. Now, what I should have done, just to show you where this comes into play, right here, alpha equals 0.05. This is the hypothesis test value, like the critical value, critical area, the level of significance for our p-value for the slope for our regression. Okay, so 0.05, we have a p-value of 0.0002, so obviously much smaller than that. So what that means is if this p-value is bigger than alpha, then the slope, we can't conclude that the slope is anything other than 0, which a slope of 0 is a horizontal line about the mean. So the average value of the mean, right here, the 20.09 or 20.1, that would be our predicted value. We would have a value of the average value for the gross, whatever the average value for gross is, that would be our prediction, because the slope would be horizontal, which means it doesn't change. So everything, no matter what the budget is for the movie, that wouldn't affect what we would expect the gross to be. But that's not the case here, because we are getting a p-value indicating that the slope is significantly non-zero, meaning that it's either going up or down. So that 1.3 is significant for the slope. Okay, that 1.3 is significantly different enough from 0 to where we actually would plug into this. Okay, if this p-value was too big, if it was bigger than 0.05, then we wouldn't put anything in for there. We would say 0 is the slope. Okay. Alright, but same thing as before, we would just plug in 115 into that value for x there, so 1.3 times 115, alright, that's 1.3 times x, which is 115 plus the 20.1. So 169.6.